Hi friends, I hope you are doing well and I'm going to share the second part of the engineering question whatever asked in Tata AIG data engineering. So I'm requesting you keep subscribe my channel and keep watching and keep like share my videos so I can grow and if any suggestion from your end so I it would appreciated I will implement in my upcoming video. So I'm going to start questions. So for another question they have asked, what do you understand by broadcasting and why it is used? So simply I told broadcasting is a technique in which in Spark Apache Spark to optimize join operation and other computation that involve in large dataset and relatively small datasets. It involves sending a small dataset to all the worker node in the cluster so that it can be used locally on each node during computation, thereby eliminating the need for expensive shuffle across the network. So they asked why broadcasting is used. So there are several factors. It depends on the several factor. Uh, so so here first optimize join. So once I will for optimize join, Spark typically perform shuffle operation for join operations where data is moved between partitions. So what happened? Broadcasting the smaller dataset avoids shuffling and distribute the smaller dataset to the or to all the nodes on there. And another part is reduced network traffic. So with what broadcast variable, only the broadcast join only the smaller dataset is sent to the each node and avoiding transferring large dataset over the network and improve the performance. So improve the performance means join the involved casted data sets run faster because they avoid network communication for shuffling. Then enhance memory efficiency. Since the smaller dataset is cached on each node, so repeated access is quicker on there. So another part is that how broadcast working on there. So Spark drivers send the smaller dataset to all worker node in the cluster. Each worker keeps a local copy of the broadcast dataset in memory. When processing the large dataset, each worker can directly access the broadcast dataset without network communication. So another part, when to use broadcasting. So size of the, suppose I know the size of the data set. Yeah, I size of the data set. Suppose one table I have a use and one table is for mapping only. Then what will I do? It depend on the size of the smaller data set. So typically whatever you typically used when the smaller data set can fit in the memory of the each executor, and joins are lookups used in the operation like joins or lookup where an one dataset is significantly smaller than the other on there. So I'm going to example of broadcast. Give the example of broadcast and scenario. You have a large data set of sales record and a small data set of region codes. So you want to join the data set on the region id column. So what you will do, simply you will read that huge data whatever you have. Then you have to read another that region code data. Then what you will apply the regular join. If you want to apply the regular join, then what will happen? If this is the regular join syntax, this is the regular join syntax. If you are going to perform the regular join, then what will happen? The region df is small, but Spark is still shuffling the sales df across the network on there. If I'm going to use broadcast join, then what will happen? So simply what if I'm doing the broadcast region df, whatever small df is there based on the region id, then what will happen? Advantage will happen, the region df is broadcasted to all worker node and avoid a shuffling on there. So the part is, what is the benefit of broadcasting? Benefit of broadcasting: so faster competition by avoiding shuffles, better utilization of network bandwidth, improve performance for small data set in distributed system. Then what is what is the limitation? So limitation is the memory constant. The broadcast data set must fit into the memory for each worker node. Otherwise, you will get the out of memory issue. Serialization overhead. So broadcast involves serialization and deserialization of data set, which can be costly for large data set. If we have a huge amount of suppose I have a large data frame, I want to do broadcast, so that time serialization overhead occur on there. Manual specification. So you need to manually identify which data set to broadcast on there. Then another question arises, why do we have a broadcasted small data frame? Why we are not doing the broadcast on a bigger data frame? Then there are several factors involved. So broadcast is primarily used in Spark to optimize operation involving a small data frame and large data frame. So the main reason for broadcasting a small data frame area is that first, reduce data shuffling. First priority is reduce data shuffling from problem without broadcast. Suppose I am doing a join, applying the join without broadcast. So what will happen when joining two data frame? Spark typically shuffles data across node so that rows with the same key and end up on the same partition. This shuffle operation can be very expensive in term of time and network bandwidth on there if I'm applying the broadcast solution. So by broadcasting the small data frame, Spark avoids shuffling the large data frame. Instead, the smaller data frame is sent to the each executor, enabling localized join operation. Now, going for the second point. Second point is nothing but a faster join operation. So join is a large data frame with a small data frame is faster when the smaller data frame is broadcasted to all the nodes. So since the smaller data frame is already available on every executor node, so Spark doesn't need to move data across partition for the join. Now another part is efficient use of executor memory. So when the small data frame is broadcasted, it is stored in the memory of each executor. This eliminates repeated input output operation and make the lookup or join operation very efficiently on there. Another part is scalability. Scalability is nothing but broadcast scale with the size of the cluster. The small data frame is distributed to all the worker nodes, so each work executor process it pa- uh, each works executor process its and partition of the large data portion of the large data frame independently and using the broadcast data. Then another part simplify logic for the small references. So broadcast join are particularly used when one data frame is small and used as a lookup table. So for instance, a data set contain region code or product mapping can be broadcast during a join. So when to broadcast a small data frame, when to broadcast a small data frame. So size constant. The small data frame should fit comfortably in the memory of each tutor. Spark handle this automatically, but as a rule of thumb, a small data frame should generally be a few megabyte, like less than 10 MB. If more than 10 MB, should not. If we don't know the memory size, what is the executor node memory size? So that time, it is not a performable, optimizable. So we have to keep in mind the data frames. Small data frames should generally 10 MB. One data frame is significantly smaller. Broadcast is ideal when the small data frame is several order of magnitude smaller than the large data frame. Frequent lookups are joined when the smaller data frame is used repeatedly across multiple transformation. Then we are going to use a small data frame. So benefit of the broadcasting small data frame. So avoid shuffle cast means if I'm doing this small data frame as a broadcast, so then what will happen? Reduce avoid shuffle cast, reduce expensive network communication, improve joint performance, particularly for large data frame. Join with a small lookup table, it will improve the performance, joint performance. So executor perform join locally using the broadcast data. Okay, and simplifies reuse. A small data frame is cached on the each executor for reuse. Each executor for reuse. Then another question he asked, what problem you faced when you broadcasted data frame? When you broadcasted data frame means when you broadcasted larger data frame. So broadcasting a larger data frame in Spark can lead to several performance and resource issue, as Spark is designed to handle large scale distributed processing and does not favor broadcasting large data sets. So below are the key problem that arise when broadcasting a large data frame. First, memory constant. So suppose I don't know the memory size. If I'm going to broadcast large data frame, then it will give the O issue. So means the entire broadcast data frame must fit into the memory of every executor. If the data frame is too large, it can lead to executor memory overflow. Executor may run out of memory, causing tasks to fail. Other second part is garbage collection overhead. Frequently, memory cleanup lead to insufficient processing. Impact this limit to the scalability of the application. Another part, increased serialization and deserialization overhead. So issue when working with a broadcast larger data frame, if I'm doing broadcast involve serialization the entire data set and send it to the all executor. So larger data set require more time for serialization and deserialization. This means it create impact high CPU usage and slower job initialization. Another part came issue came high network traffic. So issue if I'm working with a large data frame, so if I'm doing broadcasting a large data frame, send it send it over the network to all worker nodes for a large data set. This can result in network congestion, slow down other tasks running in parallel, cluster wide slowdown, increased latency due to the heavy network on there. Another part, disk spill. So disk spill is the, but if executor cannot store the broadcast dataset in memory, it is spill to the disk, and disk is input output is significantly slower than the memory operation. You know that. That's why the memory competition will come in the picture. Impact what happens? Several performance degradation on there. Then what we have to do? Imbalanced cluster resources utilization uses on there. So executor will with limit resource memory and CPU struggle more than large broadcasts, lead to skewed task and execution time across the cluster. So then what will impact? Increased job duration due to the struggler task, you know that. Suppose there are 10 nodes, and one out of 10 nodes, one node is taking time to complete the task as usual to a previous one, and every rest executor are running fine. So what will happen? So the driver will ask the task and cancel that node job and assign to the different node which is performing better. This is the type of struggler. I will let you know in upcoming video. Okay, so job failure. What is job? Then it will cause a job failure. If I do, if memory is not able to handle, then it will cause a job failures. If the broadcast dataset exceed the maximum allowable size of memory, it can cause the job to fail entirely. For example, like you can see that failed to execute broadcast in 30 seconds, and Apache, this one memory allocation is unable to acquire sufficient memory, and there is another problem is will give heartbeat timeout error, something like we have faced in Databricks when we are executing such type of work on there. So we have to care about the memory size. Whatever we have memory size, according to we have to broadcast the our particular data frame. Then what happened? How to mitigate issue with the broadcast larger data frame on there. So for how to mitigate on there, so avoiding large data frame to be broadcast. Use default shuffle join for large data frame, letting Spark shuffle data to perform the join. Optimize broadcast threshold. So Spark automatically broadcasts small data set based on the Spark SQL auto broadcasting join threshold setting. Ensure the threshold is not too high for your cluster. So you have to how you are setting that Spark dot config dot set Spark SQL dot auto broadcasting join threshold. This is the thing. Then another part is that partition and bucketing. So partition or bucketing large data set to optimize shuffle join and reduce network overhead on there. And then another part is filter the data set. So reduce the size of data frame to be broadcasted by applying filter or selecting only required column as per our requirement. So we can we can create a small data frame, and then we can broadcast that data frame over the every executor on there. Then increase the cluster resource, so scale up the cluster resource, memory and network bandwidth if broadcasting large data frame is unavoidable. It is important to do the things, then you have to increase the cluster resource. Then another question will came arise when I am saying broadcast a particular data frame, it should broadcast, but why is it check size? If I have multiple partition, and all the partitions should whether all the partitions should go all the executor or not. So size constant I have already explained above. I am going to give the answer from here. I have multiple partition on whether all the partition should go all the executor or not. So when you broadcasting a larger data frame in Spark, the concept of partition become irrelevant for the broadcasted data frame itself. So let me explain in detail how broadcasting work in this scenario. So what happened during the broadcast? So entire data frame is collected on the driver. So Spark collect the entire data frame, all partition on the driver node. Then the collected data frame is serialized into the single object and broadcasted to all the executor. You keep in mind during broadcast, it will collect all the data from the all the partition and create a data frame on driver node, and then all the data frame whatever you have created all data all based on the all partition, then we serialized and then create in a single object and broadcast to the all the executor. So broadcast data frame loses partition context, loses partition context. So once broadcasted, the data frame is no longer distributed across partition. Instead, the entire dataset is sent as a single copy to each executor. Single copy to each executor. So executor use the broadcast data in memory for their computations independently of the original partition. Independently of the original partition on there. Then another part will came. How does Spark manage partition? How does Spark manage partition in this case? So for the non-broadcasted data frame, the partition remain as they are. Spark process the data partition by partition, but the broadcasted data frame is fully available in memory on each executor. So here how the interaction work on there. So partition processing. Spark process each partition of the larger data frame on the respective executors. For each partition, the executor look up the broadcast data frame in the memory to perform the required operation like join, lookup, anything as required. So broadcast data is shared across all the tasks on executor. The broadcasted data frame is stored in memory on each executor. So task running on the same executor across the same in memory broadcasted data frame, avoiding the redundant memory uses on there. Then another question will raise why partition doesn't apply to broadcasted data. So partition is the mechanism for distributing data across the cluster to parallelize computation. So however, when you are broadcasting data, the data is replicated into its entirety to each executor, so making partition unnecessary, making partitioning unnecessary. Executor operate on their assigned partitions of the large data frame, while referencing the broadcast data into in memory. So for today, it is sufficient. From next session, I will share another set of question whatever they have asked during that interview. So I'm requesting you, please like, subscribe, and my channel, and if any suggestion required, it is appreciated. Thank you very much for watching.